This is your video lesson on Chapter 12, Section 1, comparing two proportions. What we're talking about is comparing two categorical variables, like gender and eyewear, and we'll be comparing two proportions inside of it, maybe just the contacts between genders, or just glasses between genders. Here are some notes of mine based off of what you read and took notes on yesterday, just to check to make sure everything's okay. The null hypothesis says that the difference in proportions is 0, or that they're the same, no difference. Alternative is that they do have a difference. This is just like two sample, only we're doing it with proportions. Conditions. Sample sizes need to be big enough. More importantly, each box in the 2A table has to have at least 5. In our example we're going to do today, you can see all the central 6 boxes have at least 5. The test statistic is a Z distribution. It's Z because we're dealing with proportions. Proportions are always Z. You can see the point estimate, the difference between the sample proportions. Standard error is this funky formula, P hat Q hat times this, take the square root. P hat is a pooled proportion. And I get this P hat inside of here, not P hat sub 1 or P hat sub 2, just P hat, by pooling the two samples together, X plus X for both. So how many there are in each category divided by their sample sizes added together. Z as always is the point estimate minus 0 divided by standard error. Point estimate minus 0 divided by standard error. Probability, since this is a Z or a normal distribution, we use the Z table in chart. And that is from in the book. This that used to be on the wall, well, still is. Hopefully we get to see it again. And this one in the back of the book as well. Confidence interval states how much the difference may be, just like two sample. Test tells me if there's a difference. Confidence interval tells me how big that difference might be. We're going to go over very quickly the answers from the homework I assigned yesterday. Here are the answers. Let me turn sideways real quick. You can pause and take a look at the answers. Just going to quickly go over these. Number 2, you can see the crimes for a victim's religion. Definitely a bigger difference than for sexual orientation. So the answer for A, which one seems to be related? The one that shows the bigger difference, religion. So since it shows a difference, it would get the larger z-score, difference, and the smaller p-value, difference. The not-so-large z-score and not-so-small p-value would fit for sexual orientation, because there is no difference. Number 5, give us a nice printout from Minitab. Females had a higher percentage who carry cell phones than males, higher by 3% to as much as 19% higher. Z-score fairly large, p-value fairly small. So the answer was large Z, small p. Is there evidence that there is a difference between the proportions? Yes, small p-value. And again, the difference by 3% to about 19%. I do want to do one more. Take a look. This is number 8. If you want to read the problem on your own, you can. I just want to focus on the output. I can see confidence interval is almost 0, basically 0 to about 3.5%. And look at the z-score. Z-score is about 2, p-value about 0.05. Explain how the interval is consistent with the results of the z-test. What we're looking at is borderline result here. This has an edge of 0, borderline result there. And take a look at one example together. And then I'm going to assign some practice problems. What you see on the screen right now will be posted as a document in connection with this video. When we're doing well, really anything with a C to C, we're talking about two categorical variables. When we're studying these, what we're looking at is we want to draw conclusions or an inference about a relationship between these two, or just about proportions. So first thing we can do is test a claim about proportions. So we just talked about. We can also estimate how much the difference is in an interval. We just talked about. Can we test to see if there's a relationship between the two variables? Well, that is not what we are testing right now. We're going to do that in section 2. So we cannot make a statement about the two general variables right now. We're only going to study specifically in our first example, test the claim that females are more likely to wear glasses. So we're only studying these two numbers, male and female with glasses. So I have those here. Test that claim. Test the claim that females are more likely to wear glasses. So my null is that the proportion of females equals proportion of males that wear glasses. Alternative, that the females are greater than the males. Conditions, yeah, we have at least 5 in each box, and the sample sizes are big enough to be normal. P hat means I'm going to take the 2 counts divided by the 2 sample sizes. Now the 2 counts are 32 and 37, and their sample sizes for male and female, 282 and 164. So I add 32 and 37, and then I add their sample sizes, the n values, 446. 69 divided by 446. You can also find those numbers in the two-way table right down here. Total of glasses, total, regardless of gender, and the total. When you divide those two, I get p hat of 0.15. Point estimate. So I need to calculate the proportion of males. There's 32 males that wear glasses out of 282, 0.11. Females, 37 out of 164, approximately 23. So the point estimate is the difference between the proportions of females minus males, 0.12. Standard error calculation. We have this formula. We calculated p hat to be 0.15 up here, times its complement, 0.85. And I do 1 over n plus 1 over n using the sample sizes. Take the square root of all that, I get 0.035. So z, again, point estimate minus 0 divided by standard error. Point estimate, the proportions differed by 12%, minus 0 over the standard error of 0.035, gives me this z-score. Now we know for z-score that's very big. So probability is approximately 0. Now I'll get to the conclusion in a moment. Let me do the interval. The interval says take the point estimate, 12% difference between the genders, plus or minus z, 1.96, or 2, times the standard error we calculated, 0.035. 0.05 to 0.19. So what can I say? If H sub O is true, there is almost a 0% chance the sample proportions would be that far apart, or 12% apart, our point estimate. So we reject the null. It's very unlikely that our sample would occur if the null is true. Therefore, the null is probably not true, so we reject it. We have convincing evidence that females are more likely to wear glasses. By how much more? That's what our confidence interval gives us. 5 to 19% more females wear glasses than males. A couple of quick conditions and behaviors. This also matches what is on the document 1, 2, and 3. First of all, how do I know that there's going to be no bias? And that's the at least 5 in each box. One other thing, that pool proportion, that special p hat that we found, is if it is close to 1 or 0, to the extremes, then you're going to be more likely to reject. The spread will be smaller, z is bigger, p is smaller, more likely to reject H sub O. That means if it's close to 0.5, kind of in the middle, more conservative, the opposite is true. The spread's going to be bigger, z smaller, p bigger, not reject is more likely to occur. In addition, the sample size thing that we always talk about is true. If sample size is bigger, spread is smaller. Z is bigger, p is smaller, more likely to reject. You can pause and take a look at those if you need to. That wraps up our lesson. I am going to ask you, and I'll have this in the post, that you do the more practice problems. Number 1, A and B, about gender and fear of going to the dentist. And number 2 on the next page, about drug and placebo and if it improved in the patients. And you're just finding the confidence interval for this one, seeing if you can draw a conclusion from there. Below that is a technology section that gives you more practice. These two problems, this draws on the just use of the calculator, not using the formulas by hand, and I'll show you where to get those real quick. It should be very easy for us at this point. In the Stats app, we go to Test. It is Z because it's proportions, and you see a 2 proportion option, and that is where you'll put in X and N for both samples. Same thing holds true for interval, Z, 2 proportion, and again you can see all that there. So again, we are working with 2 categorical variables, 2 proportions, and I need you to practice the 2 more practice with the formulas, and then the 2 technology practice problems as well. Let me know if you have any questions by emailing me or sending me a message through Google Classroom.